A shader graph enables you to build shaders visually using a network of nodes and connections. A typical shader created using shader graph looks like this. The result is a web-like structure that replaces the handwritten code normally associated with writing shaders. But the objective is the same. We want to create a mini program to talk to the GPU and change how the material renders on screen. The shader graph window is broken up into a few distinct regions. Most of the workspace is just this gray empty area of the window where we make our nodes. Eventually, the graph terminates in a single node that serves as the shader's output or master node. This little palette off to the side is the blackboard. Basically, it shows publicly exposed properties. Most of the shader's inner workings are hidden, but this allows a small part of the graph network to be accessed via the inspector, and we'll see this in action in a little bit. And somewhere in the lower right, we have the master preview, which demos your shader on a primitive or a mesh. In the main workspace, we create our shader by connecting nodes into a graph-like network, and hence the name shader graph. The workflow is that we create a bunch of nodes and operators, connect them all together, and funnel them into this master node, and that tells Unity how to render the material in the game view. The graph framework gives you instant feedback as you apply changes, making shader creation really interactive and fun. Of course, this is a finished shader, or one that's pretty far along. When you open up a brand new shader graph, like our highlight shader, you'll get something a bit more plain. Again, we have our blackboard, our master preview, and our PBR master node in the interface. The shader graph window itself is much like any other window in Unity. You can dock it in the main Unity layout or just keep it floating. That's up to you. I'm going to park it here above the game view. At any time, you can always maximize it from the context menu above the tab, or use the Shift spacebar hotkey to toggle the currently focused window in and out of maximize. That's really handy when you want to use the screen real estate for editing your graph and then jump back to the multiple view layout in order to see the results of your shader in your scene. We always start with one node that is labeled PBR master, and that's the master node, essentially the output node. Use the middle mouse button to drag and pan the view around the workspace. We only have one node right now, and this is best shown on a more complete graph, so let me just demonstrate on a shader graph from another project. Again, we use the middle mouse button to pan the workspace, and we use the middle mouse wheel to zoom in and out in case your graph gets large and you need a general overview of everything. If you lose your place in the work area, you can always hit the A hotkey to frame all of the nodes on screen, or use the F hotkey to frame any specific single node that's selected. This will all make sense when we start creating more nodes, so don't worry, you'll get tons of practice using these shortcuts to navigate the work area after our shader graph is more filled out. The blackboard and preview window UI elements should stay put as you adjust the nodes in the workspace. They aren't affected by those shortcuts, but you can position them on screen by dragging their title bars. Each one also has a little caret to hide or unhide its preview thumbnail. For now, let's just jump back to our bare bones highlight shader graph. You should notice that the PBR master node has a number of ports that correspond to the various material properties. There are a couple of extra ports like position and alpha clip threshold, but the rest of these ports should have really familiar names. Albedo, normal, emission, metallic, smoothness, occlusion, and alpha. All of these correspond to what you see in the inspector whenever you're looking at a material using the standard shader. As we modify our shader graph, we're going to change these properties procedurally and then change how the material renders on screen. The simplest shader we can make is just one that has a solid color. So if you click on the color chip next to albedo, we can change the base color of our shader. If I click that, and let's change it to a shade of blue, for example. If you unmaximize our window to see the results in our scene, you'll notice that nothing really happens yet, and that's because the changes need to be saved in the shader graph before they can take effect. So we can just click Save Asset in the upper left-hand corner, And now the blue color will actually affect the shader. Now that in turn tells the material to render as blue, and so the hard hat turns blue in our scene. And that's the simplest shader that we can create, but it's not really useful unless you have a need to color your game object this specific shade of blue. If you look at the material in the inspector, you'll see that we don't have any input into what the shader and material are doing to the hard hat object. At minimum, we want to allow the user to decide what color to render the geometry, and here is where we can use our blackboard. Back in the shader graph, let's maximize our window. Instead of hard coding the input color of the albedo property, we want to let the user pick the color. So let's create our first node outside of the master node. The UI allows you to create nodes in several different ways. The first way, and a very common way, is just to right-click over the workspace and then select Create Node. You'll see that the interface changes to the Create Node dialog box, and there are dozens of nodes available for us in here. You can just browse around, and we want to find a basic node to select a certain color. You'll discover the node that we're looking for under Input, Basic, Color. Now, it will take you some time to get used to how all of these nodes are organized in this interface. I definitely encourage you to explore at this point and just see what all the nodes are called. Now, you also have the option of searching for a node by name using this filter field at the top. In my case, I know the node is named Color. I could start typing out color in the filter, and it will show me all of the relevant nodes filtered by name. And then I could just select color from that list. Once I have the color node created in my workspace, you can click the color chip to edit the color that you want. Instead of the default black or the blue that we used earlier, let's choose a completely different color, and I'll choose a shade of red instead, but you can pick anything aside from black or blue. Now, the other thing we can do in this node is switch the mode from default to HDR. We don't really need the high dynamic range, so let's just keep it at default. Now that I have some color data in this node, I want to send this data to the albedo property of the master node. And you do that simply by left-clicking on this small port or circle in the UI, and then dragging a connection to the albedo property of the PBR master node. Once I let go, you'll see that the color chip next to the albedo property disappears. We've replaced it with this color node. The master node and the master preview thumbnail both show up with my new red material. But if you go back to the main scene, you'll see that our hard hat remains the same shade of blue. You won't see the results of your shader graph shader until you save it. So click Save Asset, and now our hard hat turns red. Of course, we're in the same situation as before. We've effectively still have a color hard-coded into the shader graph, even though it's a different color. And here is where our Blackboard UI element comes into play. We can convert the color node into a property. Right-click over the color node and select Convert to Property. When we do that, we lose the ability to edit the color node directly. Instead, we get a property called Color exposed in the Blackboard. If you click on the caret next to the name, you can open up a drawer, and you'll see that the color property has all of the data that we could set directly in the color node before, plus a couple of extra things. We have a check button to indicate whether the property is exposed in the inspector, so we'll just leave that checked for now. And we also get a specific ID reference. If you do some scripting and you want to refer to this color property in your scripts, this is the identifier that you would use. And then we have our color chip and mode just like we had before. If you click Save Asset and now go back to the main interface, select the material. In the inspector, you now see the color property that we exposed in the Blackboard. We can now edit the color chip in the inspector, and now this shader becomes much more useful. This allows you to select a solid color, whatever color you want, and make your object a custom color using our shader graph. Okay, now this isn't a spectacular shader by any stretch of the imagination, but I'm hoping that the workflow with how we construct shaders in shader graph is becoming more apparent. We create a network of nodes, pipe that into a PBR master node, and then you expose what properties you want to show in the inspector using the Blackboard. And of course, we want to set up more nodes to make for a more interesting shader. So let's go to our shader graph shader and just do more than just show a single flat color.